our last section in college algebra. It's one random section in chapter 7 that we have to cover. It's 7.4 nonlinear systems of equations, and we only have to do objective 1, which is solving nonlinear equations. Objective 2, I think, is nonlinear systems of inequalities, which we don't have to cover. So objective 1 just says, remember a solution of a system of equation is an ordered pair or an ordered triplet that satisfies all the equations in the system. Graphically speaking, it's where one would meet the other, so where the two graphs intersect. In the past, we've used substitution, but we've actually used elimination, or we've used matrices and so forth. We won't use those methods in this section because we have nonlinear things, meaning our variables are raised to different powers other than just x to the first, y to the first, okay? So what we're going to be using in this section, guys, is substitution. Or no, we won't be using substitution, sorry. In general, we use substitution, but in this section, we're going to be using substitution if it's linear, so that's method 1. Elimination if it's nonlinear, so that's method 2, okay? What does that mean? It means one of the two will always be nonlinear, but one of them might be linear, which we can use substitution pretty easily. Or if they're both nonlinear, we're going to use elimination, meaning get the variables to cancel out. You know, have the opposite signs and get them to cancel out. So I'll ask you to show the algebra used to solve these systems to receive credit. However, we can actually check everything on our calculator. So I'm going to get my calculator out too, just so I can show you once we're done, okay? So this first one, what we have here, I know you're not familiar with all of them, but this is x squared plus y squared equals 25. This is actually an equation of a circle, okay? And then 3x minus 4y, this is called a linear function, meaning it's a line. So we just want to see where a line would intersect a circle. How many answers do you think we would have? How many ways can a line intersect a circle?
2.
2, most likely, okay? Just hit at one spot. But most likely, guys, just to kind of give us a little picture, it's going to look something like that. And we're trying to find these intersection points. Okay? I just drew it roughly. I don't know if it's an increasing line or decreasing line. So, all right, so we're going to actually use method 1. So up here in my notes, I had labeled 1. If one of your equations is linear, we're going to use substitution. What does substitution mean? It means solve for one of your variables in the linear equation and just substitute it back in for the nonlinear equation. So we can either solve for x or y. It doesn't matter. Which one do you guys want to solve for? X? Let's solve for x, all right? So what we're going to do is we're going to solve for x, so leave x alone and move the 4y over. So 3x equals 4y. So this is going to be step number 1. How are we going to get x by itself? What do we need to do?
Divide by 3.
Divide by 3. So x equals 4/3 y. What does that mean? It just shows you how x is connected to y. So if I say, oh, y is 12, you can plug 12 in, do the math, and figure out that x is 16 or whatever it may be, okay? So this shows you your connection. So step number 2 is once you isolate one variable, plug it into the top one, exactly, or the other one. So step number 2 says anywhere you see x, we're now going to substitute in 4/3 y. So we have x squared plus y squared equals 25, right? But in for x, I'm going to write kind of long, 4/3 y squared plus y squared equals 25. We just substitute it back in, all right? And the whole idea is now we've taken an equation with x's and y's and reduced it to an equation with just y, so we should be able to solve, all right? So since all of x was squared, all of 4/3 y should be squared, so it means square both parts, all right? How do you square 4/3? Well, you just square the 4, square the 3. So what is 4 squared? 16. What is 3 squared? 9. And what is y squared? Y squared. Is that okay so far? And then we can combine like terms. I know it looks weird, but what is the coefficient of the second y squared technically? 1, right? So in your calculator, guys, you can do 16/9, so 16 divided by 9 plus 1, hit enter, and then hit math frac. What do you guys get? 25 over 9. So 25 over 9 y squared equals 25. All right? We want to get y by itself. Who's in our way right now?
The 25.
The 25/9. How do you undo multiplication? divide, but how do you divide by a fraction? You just multiply by the reciprocal, right? Or in your calculator, you can type 25 divided by, parentheses, 25 divided by 9, however you need to do it, okay? So if you do it by hand, if you multiply by the reciprocal, the 25 up here would cancel out with the 25 on the bottom. So you should just get 9. If you do it in your calculator, just make sure you get 9. Did you get 9? Okay. So y squared equals 9. And again, you can do 25 divided by, parentheses, 25 divided by 9, parentheses. All right, so what's the last step we have to do to solve for y? Take the square root, but when you put the square root there, what do you have to remember to put in front of your square root?
Plus or minus.
Plus or minus. So y equals plus or minus 3. What does that mean? It means, see how we had 2 points? One of the y values is a 3, one of the y values is a negative 3, all right? So how do we find x? We plug it back in, right? We knew x was 4/3 y. So let's figure out the 2 different x's we'll get, right? So let's use the positive 3. So x equals 4/3 times positive 3. You can do that in your calculator, or just remember fractional math. That 3 on the bottom will cancel out with that 3 on the top. And I'll just leave you with what? X equals 4. So what is its ordered pair? The x value was 4. What was the y value we plugged in? 3. You got it. And then my other branch was the other option for y. What was the other y? You got it. So x equals 4/3 times negative 3. Same idea as before where the 3's will cancel. It's just that the negative won't cancel out. And so instead of a positive 4 remaining, you'll have a negative 4 remaining. So x equals a negative 4. So again, what was our x value for that ordered pair? Negative 4. What was the y value? Negative 3. Okay? So algebraically, you can check these two answers. Plug 4 in up here. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. But negative 4 squared is 16. Negative 3 squared is 9. Add them together, you'll get 25. They'll also work algebraically on this side. 3 times 4 is 12. 4 times 3 is 12. 12 minus 12 is 0. Or do it with the negatives. 3 times negative 4 is a negative 12. But that negative 4 times that negative 3 is a positive 12. Negative 12 plus 12 is 0. So how do we do this graphically, guys? Well, what we need to do, and I'm going to write it on here real quick, and if you don't ever do it again, that's okay. I just know it's like a nice check. So here's our calculator check. For our calculator, we have to isolate y for both, okay? So if you isolate y in this equation, 3x minus 4y equals 0. Negative 4y equals a negative 3x. So y equals a positive 3/4 x. That's what we're going to put into y1, okay? y1 is just taking our linear equation and solving for y. You need y equals mx plus b form, basically. y2 is the same idea, but we're going to take x squared plus y squared equals 25 and isolate the y there. So what's the first thing we need to do? Subtract the x squared over. So you have y squared equals 25 minus x squared. How do you get the y by itself? Nope. Square root it, but when you put a square root there, what do you need? Plus or minus. So y equals plus or minus the square root of 25 minus x squared. So just make y2 the positive square root and y3 the negative square root. Okay, so we'll put this in our y1. It's going to be the line that goes across. We'll put the positive root, it'll be the top half of the circle into our y2. And then we'll put the negative, that will be the bottom half of our circle, and we should see where they intersect, okay? So get your calculator out, and we're going to go to the y equals. Try to put this on here where it doesn't. So I'm going to turn mine on, and I have y equals. I'm going to clear what I have. All right, so in my y1, I'm putting my equation, 3/4 x. Is that okay? In my y2, I'm putting the top part of the circle. So I do square root. Everything should be under the square root. 25 minus x squared, close it off. And then here, before I type the square root, make sure you put the negative. Don't use the minus symbol right here. Use the negative symbol that's down here by the enter. Hit second square root, 25 minus x squared. Close it off and hit graph. So y1 is your line, so it should graph the line first. y2 was the top half of your circle. y3 is the bottom half of your circle. It doesn't look like a perfect circle. It kind of looks like an oval, but that's just because our window's rectangular, okay? So if you wanted to look more like a circle, if you hit, I think it's window, nope, I lied, zoom, square. If you hit zoom and see how number 5 says square, it kind of makes it more square. That's only if you're really picky. Like, we understand it's a circle, we're not going to get picky that it looks like an oval. But see how that looks more circular? All right, so what we just found algebraically are these 2 points, but how could you find that using your calculator? We use this trace feature, which we've done before. So see how you have calculate right above the trace? If you hit second calculate, we want to do the intersect feature, okay? So you scroll down to number 5, and you see this flashing cursor. Let's go look at this one down here first.
I think I entered mine in wrong.
I'll double check yours, okay?
Because it'll do it like halfway and then it says quit.
Okay, so I'll double check. Maybe make sure it's the negative symbol, not the subtraction symbol in front of your y3, okay? So the first curve, there. See how it says first curve question mark? See how it's on y1? You're like, yeah, that's my first curve, so hit enter. Then it should jump to the second curve, y2, that's perfect. And they say guess question mark, you say yes, and it should find up here where y2 intersects y1, 4, 3. All right? We're going to do it again, but this time if I want to be down here, I want it to intersect with y3, not y2. So I'm going to do second trace, intersect, and I'm going to come down here to kind of move towards it. I say, yes, that's my first curve. Then I don't want y2, the positive, to be mine. So how do I get this cursor down here? I just arrow down and see how he jumps to the next curve. Okay? So we want him on the second curve, so it should say y3, and you can move it with the arrows. And then you hit enter, guess, and you should get the -4, -3 there.
I don't know what my calculator's doing.
All right, let me double check.
I went to do the trace and then it did this and it won't go to it.
Oh, you have stat stuff going on.
I don't know what happened. And I'm sorry if my stomach growls during this lecture.
I didn't get any negatives. I got 4 and 3.
Okay, so when you go to do it again, so you do second trace again, so do second trace again, choose 5, intersect, okay, enter. See how it says, is this the first curve you want? Yeah, you want to know where the line's intersecting it, so just hit enter.
Okay.
And then it says, do you want the second curve to be y2? No, you want it to be y3, so just, no, don't go to the right, just arrow down. And see how it went to y3?
Okay.
And you hit enter. Oh, goodness. Okay, so let's try it again. So we'll do graph, second trace, 5. So we're way off the chart. So let's kind of go towards where we're wanting to intersect the bottom curve. So do you want y1 to be your first curve? Yeah, we want that line to be your first curve, so we hit enter. Do you want y2 to be your second curve? No, that would be that intersection, right? So what I'm going to do is arrow down, and it should jump right down to the bottom curve. See how I did that? Do you want y3 to be your second curve? I do. So I hit enter, and it says guess question mark. You hit enter one more time. It should give you the negative values.
Okay.
So since our curve, our circle, guys, is made up of 2 curves, when you do the trace feature, do it once where the second curve is y2, but do it a second time, but make the second curve y3. And guess what? We'll have another one like this so we can kind of practice it again. And I'm looking at the algebraic, you know, that's what I'm going to want to test you on and see, but it's kind of nice to just know that you can do it graphically. All right, if there's no question on the front page, like I said, we'll have a chance to check each one of them with our calculator.
We're halfway through.
We're halfway through, thank you so much. Okay, so then we're going to look at example 2. What we're going to notice on example 2 is both of our equations have x squared, y squared. So they're both nonlinear. So if you refer to what we said on there, if they were both nonlinear, we're going to use the elimination method. Anybody, anything stand out to anybody about how we can eliminate what variable first?
Probably 1.
The y, because do you notice with the y's, they already have the opposite signs? So I'm going to take these two in step number 1, and what am I going to do to the bottom curve so that it cancels out with the top curve?
Yeah, multiply 5.
Multiply by 5. So remember, my way of doing it is just showing that. So I'll keep the top curve 2x squared plus 5y squared equals 39 the same, but I'm going to multiply every term on the bottom curve by 5. So I'll get 15x squared minus 5y squared equals negative 5. So it's kind of like what we did in 6.2 before we learned about matrices, how to solve for them. All right, so we can add the x squareds together. What are we going to get there? 17x squared, is that okay? What's going to happen with our y's? They'll cancel. And then what's 39 minus 5? That's just 34. How do I solve for my x? What's the first move I need to make?
Square root.
Not yet. Divide by 17. So you want to get rid of anything in front of it first, right? So x squared equals 2. Now what do I want to do? Square root. But when I square root, what do I need to put in front of that square root? Plus or minus. So x equals plus or minus root 2. Oh, sorry, I forgot to tell you. So what we're dealing with, the top one, guys, it looks like a circle, but if the coefficients don't match, it's actually called an elliptical, which is just a fancy word for oval, okay? So notice on this front one, actually I can just show you right down here. On this one, see how x squared and y squared both have a coefficient of 1? That means it's a circle. If they both had a coefficient of 4, it'd be a circle. So this is an elliptical. And then this, when they have a minus in there, is called a hyperbola, and it's like an opposite of elliptical. So what are we looking at? We're looking at like an oval like this and something like this kind of intersecting. So how many answers are we going to have on this one? 4. Isn't that crazy? And then these can go that way, or they can go out like, we don't know whether they'll be up or down, or maybe they go this way, you know, but either way, we're going to have 4. Okay, so we know the 2 x values, so what are we going to do? Plug in each of the x values and find our y's, all right? So step number 2, we're going to find our y's. So we can pick either one. I'm going to pick this one just because the y's already kind of somewhat isolated. So 3x squared minus y squared equals negative 1, and we're going to branch to 2 parts. Why? Because on one I'm going to use a positive root 2, and on the other I'm going to use a negative root 2. All right? So I'm going to use the positive root 2 first. So we have 3 times root 2 squared minus y squared equals negative 1. So this is kind of going back to like when we first learned about radicals. What happens when you square square root? They cancel each other out and you're just left with the inside, right? So when you square the square root of 2, it's just 2. And then what's 3 times 2? 6. And if you don't believe me, you can actually put that whole thing in your calculator exactly how you see it, okay? So that's just 6. 6 minus y squared equals negative 1. Is that okay so far?
Yeah.
All right, want to get y squared by itself? What's the first move we're going to make?
Add 6.
Not add them, because what's the sign in front of the 6 right now? Positive, so we're going to subtract him, okay? So subtract 6 over, you get negative y squared equals a negative 7. What's my next move? Divide by what?
Negative 7.
Not negative 7. I want to get y by itself. Not by y.
Oh, square
Negative
root.
1, right? So I cannot take the square root until it's y squared. And right now it's negative y squared. So divide both sides by negative 1 and you get y squared equals 7. Now what can I do? Take the square root, and what do I put in front of that square root? Plus or minus. Y equals plus or minus root 7. What does that mean? Let me come over here and start writing my answer, because there's going to be 4 of them. When I had positive root 2 as my x, I had 2 y values, correct? When I had positive root 2 for my x, I had 2 y values. A positive root 7 and a negative root 7. And guess what? The exact same thing is going to happen when we plug in a negative root 2, okay? So let's just branch off over here. We have 3 times a negative root 2 squared minus y squared equals negative 1. But what happens when you square a negative?
It becomes a positive.
It becomes a positive. What happens when you square root 2? It becomes 2. That chunk right there matches this chunk perfectly, right? A negative times a negative is a positive. 2 times root 2 just becomes 2. What's 3 times 2? 6. It's the exact same thing. And again, if you don't believe me, guys, put it in your calculator exactly how you see it. So, do we even need to go through all the motions? What are we going to get for y again? Plus or minus root 7, okay? If you need to go through the motions, feel free. Subtract the 6 over to get negative 7. Divide by the 1 to get positive 7. Take the square root to get plus or minus 7. What did these plus or minus 7s go with? An x value of negative root 2. So when you had negative root 2, you got two y values, a positive root 7 and a negative root 7. Look how crazy that is. But again, oopsie, what's nice is that we were able to find these exactly. Say you don't really know, like, I'm going to roughly write what root 2 is and what root 7 is, so when we go check it on our calculator, we can double check it. So if you put root 2 in your calculator, that's roughly 1.41. I'm going to just write that down just for reference, okay? And when you put root 7 in your calculator, that's roughly 2.65. So like 1.5-ish, 2.5-ish is where they're crossing, plus and minus versions of it. All right, so how do we graph this? It's kind of the same thing like what we did before. What we would have to do is we'd have to isolate y, okay? So I'm going to do it over here, and you don't have to do this. I'm just showing you how you could. So on calculator check. We would isolate y by subtracting 2x squared over. So we have 5y squared equals 39 minus 2x squared. Before I can take the square root, what do I need to do to get y squared by itself? Divide everything by 5. So y squared would be 39 minus 2x squared all over 5. How do I get y by itself? I would take the square root. But when I take the square root, what do I put in front? A plus or minus, okay? So y1 is going to be the positive version of all this jazz. And then y2 is just going to be the negative version of all that. Okay? And then just roughly the same kind of idea over here, guys. What we would do is we would subtract the 3x squared over. So under our square root, we'd have negative 1 minus 3x squared. But then you would divide everything by 1 and change the signs and take the square root. So just follow along with me. Even if you didn't write this down, let's follow along on our calculator because I want to make sure you can do it. So in your calculator, put y equals, clear out what you have. Okay? Go back to y1. y1 is going to be the top part of our ellipse. Okay? So with me, do second square root so we can get the square root going on there. 39, oops, and that's all going to be in parentheses, so let me do that again. So we're going to do parentheses 39 minus 2x squared, close off that parentheses. So see how he's kind of in his own chunk because we want to say all of this is our numerator, and then we need to divide by 5, and then you can close off that parentheses to say I'm closing off my square root. So you should have 39 minus 2x squared, the numerator, in parentheses, divided by 5. Now, what we're going to do in y2 is we're going to do the exact same thing, but we're going to use the negative symbol down by enter, not the minus symbol, so negative, and then type the exact same thing. The square root, and then parentheses again to say this is my numerator, 39 minus 2x squared, close off that parentheses to say that was my numerator divided by 5. Phew, okay. So that's just the first guy. The second guy, what we would do is subtract 3x squared over, so we have like two negatives going on, but ultimately we would divide both sides by a negative, so we actually have positives going on. So in y3, well, all we have to do is do the square root of 1 plus 3x squared. Close off your parentheses, he's a little bit easier. And then y4 would be the second half, negative second square root of 1 plus 3x squared. So before I hit graph, I just want to make sure you guys got that all typed in. So what you should see is like kind of an elliptical, an oval form first. So let's see if that happens if you hit graph.
Looks like football.
A football, exactly. So it's going to be a football first. And then you should see like this weird V thing going from top and bottom. That's called a hyperbola. There it is, okay? So our weird root 2s and our weird root 7s are all of these, okay? So I'm going to kind of slide this over. So this positive would be this one right here. So let's just check that one and be done with it, okay? And trust all the other ones are going to match. So hit second trace. We're going to use the intersect feature, which is 5. And notice where the cursor is, he's on the top of the football. He goes, is this the one that you want to be your Y1? Sure, the top of the football, that's perfect. So let's hit enter. Then notice once you hit enter, it jumps to the bottom of the football. Are the footballs intersecting? No, they're just parts of the same curve. So what you do is you arrow up or down. We're going to arrow down, okay? When you arrow down, he should hop up to the top of the hyperbola, and that's the one we want. We want that to be Y3. See how it says Y3 up there? You hit enter and then enter one more time. You should get 1.41-ish and 2.65-ish, and that's that root 2 and that root 7. And we could go around and do all this. Where does curve 1 match curve 4? Where does curve 2 match curve 3? And so forth, and get all the combinations. But ultimately, they're going to be the 1.41, the 2.65, give or take a negative sign. Okay? Any questions? I'm going to stop that right there because then that'll be perfect for the second half.